In today's video, we're going to be talking about the dispersion of light. After watching this video, you should be able to understand how a prism works, get a general understanding of how rainbows are created, and then understand how come mirages can be seen, say, on a roadway. All right, so let's get right to it. Dispersion basically is the separation of visible light into its different colors. Okay? And we know that visible light comes in white usually, and that is going to include all the colors of the rainbow. So this over here would be some white light, and as it enters this prism, it basically is causing the white light to split apart into various colors, and you can see here all the colors of the rainbow, which would be Roy G. Biv. Well, how come that happens? Well, basically what it is the n value of light does show a small variation with frequency. Okay, so basically red light has a lower frequency than, say, purple light, which has a higher frequency. And so there's a little bit of a difference in the n value. So the n value of, say, violet light is 1.53, and the n value of red light is 1.51. That small difference in the n value causes the light to exit this prism at different speeds, and that different speed causes basically the light to disperse into various colors. Okay, so keep that in mind, because that is going to be the key to basically a rainbow's formation. So a rainbow, like I said, also undergoes dispersion, and basically water, these little tiny water droplets, act as a tiny prism that disperses the light and then reflects it back to your eye. So here in this picture, we've got a person, okay, right here, and the sun would be somewhere up here. And there's the sun. And the sun's light is hitting a spot where there are water droplets, so it has to be raining. Okay, and so you've got water droplets, and basically the water droplets act just like a little tiny prism, and they basically create the colors of the rainbow. Now what's interesting is each set of water droplets, like here's a small pile of water droplets, they all are shooting red light to this guy's eye. These water droplets aren't just shooting only red. They have all the colors of the rainbow, except red is the wavelength that is reaching this individual observer's eyes. If someone was, say, standing maybe a little bit at a different spot, those water droplets, they might be seeing a different color. But in this case, it's going to be red that this guy's seeing. And say these water droplets that are right here, they are showing up as blue to this guy. Even though they have all the colors of the rainbow, it's not just blue that those water droplets are dispersing. At the angle that this observer is at, it's just showing up as blue. And so when you put it all together, you get all the colors of the rainbow, and you actually get a whole rainbow. Now what's interesting is if you were in a plane, so if I draw a plane here, if you're in a plane, a rainbow actually can show up as a whole 360-degree circle. It's not actually a rainbow anymore, it's actually a circle. So it's kind of a cool phenomenon that you actually are able to see. It's just when you're on the ground, the horizon gets in the way, and so you see half of a circle, which we call a rainbow. Okay. The other phenomenon that you guys probably are familiar with is a mirage. And basically, a mirage is a combination of the dispersion of light along with your brain actually kind of playing a trick on you. And this typically happens on hot summer days. If you're driving in your car, the air above, say, like a asphalt road gets heated up because, you know, blacktops absorbs a lot of the sun's light. It gets pretty hot, and so the air above it gets hotter. And hot air has a lower index of refraction than, say, cold air. So the N here is going to be lower than, say, cold air. And so when light enters into that, it exits at a different speed. And so it causes you to seem to think you see something right here, okay? Because the light is traveling at a different speed at that point. And your brain it doesn't really make a lot of sense. How come something is in the middle of the road? You know, I mean, like, is there like broken glass in the middle of the road? Did someone leave like a mirror in the middle of the road? What's going on? And the most logical conclusion that your brain comes up with in a short amount of time is that, oh, it must have rained or someone spilled water in the road, and that's what your brain sees it as. But obviously, as you know, as you drive this direction and you get to the point where the water supposedly was, it's now gone, right? It's just a road. And so that's the illusion piece. These mirages, even though yes, the light is doing something different at that point, it's not actually water, or it's not like broken glass or a mirror or anything like that. It's just an optical illusion that is in combination with the refraction of light through a non-uniform medium. Basically, you have this hot air, cold air boundary that's causing the light to shift. Okay, so that takes care of today's video. I will see you guys next time.